Next temperature, very, very important. So at the beginning of this session, we discussed temperature and heat both are not same, right? So heat is what? Is the energy. And the intensity of energy is a temperature. So you see, this is important. It's a measure of thermal activity or intensity in a body, not the heat content, not the thermal energy. The thermal energy or the heat content is a heat, but the intensity of that. So anyhow, you see, it's a measure of thermal activity or intensity in a body, or it's a degree of hotness or coldness of a given system. Means, and you can relate this point, as the temperature increases, what will happen to the rate of heat transfer? Increases, right? And as the temperature decreases, the rate of heat transfer also decreases. So temperature is not a heat, because with the temperature you cannot find out the quantity of that heat. Getting a point? And this activity is depend on the movement of molecules. Okay, so you'll get some idea. You see with this picture, everyone aware of this: solid, liquid, and gases. And you know this, in solid, the molecules are closely packed, na? And in liquid, somewhat loose, and in gases, further. And with this, you can try to understand the nature of the temperature. You see, solid means I'm talking about ice, liquid is of water, and gas a vapor. So what do you think? In which case you'll find higher temperature, solid or liquid or gas?
Yes.
Gas. And in which case you'll find lower temperature? Solid, right? So now you can relate, as the temperature increases, the movement of molecule also increases, na? You see, here the activity depends on the movement of molecule. So the movement of molecule start vibrating. So in solid, the temperature is less. That's the reason the molecule can be closely packed. The movement, because the movement is less, right? And as the temperature increases, the movement increases. So it required more space for the movement. That's the reason you'll find more space in liquid and further in gas. So I think you are getting my point. Means you can able to understand the nature of this temperature. So as the temperature increases, the intensity of that heat increases, or the movement of molecules or the velocity of molecule increases, or in other words, the kinetic movement of that molecule increases as the temperature increases. Got the idea online? And with this, you see, the rate of heat transfer also increases. As the temperature increases, the movement of molecule increases. So when the hot body come into contact with the cold body, the intensity of this hot body is high. So when it touch, so the movement of molecule, the velocity is high, so it can quickly transfer. Getting a point online? So can you able to catch this? You see, all these basics, as I said, will help you in load calculation, in manual load calculation. And manual load calculation, we are supposed to deal for the concept. And with that concept only, you can deal with the software load calculation. Okay, so all are interrelated. So please don't ignore this concept. This is very, very important. Now, further, if you talk about the temperature, you know, the temperature can be measured in different scales. No? So if you talk about English system, we are dealing with the degree Fahrenheit. If you're dealing with the, say, SI metric, we are using the centigrade, or we can use this Kelvin in metric. So we'll try to understand this temperature scales, because this will help at the time of conversion. Because in actual practice, your consultant may use English system or metric system, or many times this conversion is required. Okay, so for conversion, this the type of this scales and the difference between the scales all is required. So you'll find different temperature scales, but commonly in actual practice, degree Fahrenheit, degree centigrade, and Kelvin. Okay, we are not calling degree Kelvin. Remember, we used to call Kelvin only. And you know, Kelvin is an absolute scale. So what exactly? Here, this picture will help you to understand the clear idea. Let me zoom out. Interesting. Here I'm considering example as water in this, for this scale. So here Kelvin to centigrade, then Fahrenheit to centigrade. So first Kelvin. So you see, this is absolute zero. Absolute zero means theoretically the movement of the molecule is a minimum. That condition we can call as a absolute zero. And just now we discussed the temperature is the intensity of heat, nothing but the movement of molecules. If the movement of molecule is zero, or theoretically say zero, that we can call as absolute zero, that we are considering in Kelvin. And remember this value 273. 273 means in centigrade we are considering 0 degree centigrade, and this 373, say round off, I'm just taking round off because in application design we are taking the round off value. That much two digit or 4 digit accuracy is not required, 0 digit is enough. So 373 degree, sorry, my mistake, 373 Kelvin is 100 degree centigrade. And you know this 0 degree centigrade is what? Freezing or the melting point of water, no? Freezing point of ice or a melting point of water. Okay. And this 100 degree centigrade is what? The boiling point of water or the condenser, this condensing point. Means if you add the heat, water to vapor, or if you extract the heat, vapor to water. Okay. So this conditions, you know, everyone aware of this. 0 degrees of freezing point, 100 degrees of boiling point in degree centigrade. If we talk about Kelvin, 273 and 373. Okay, because Kelvin here is the absolute zero, and you see minus 273. And you know this, if you want to convert this centigrade, suppose to Kelvin, so we have this conversion 273, no? But you see Kelvin is not commonly used in this HVC industry. Most commonly you'll find this Fahrenheit and centigrade. So we'll discuss about this, and this is important. So remember this point, 32 degree Fahrenheit is nothing but 0 degree centigrade. Is what? Freezing point of water or the melting point of water. At this level, to avoid confusion, I'm considering a freezing point of water. Next, 212 degree Fahrenheit is what? 100 degree centigrade. Remember these values, we'll use at the time of conversion. In the next page, you'll find the formulas also for centigrade to Fahrenheit and Fahrenheit to centigrade with respect to temperature and with respect to temperature difference. So we'll discuss what is temperature and temperature difference. But one more point here. So quickly you see 0 degree centigrade equal to 32 degree Fahrenheit and 100 degree centigrade equal to 212 degree Fahrenheit. Apart from this, you can notice one more fact here. You see at minus 40 degree, the difference of both the scale is 0. You see minus 40 degree Fahrenheit equal to minus 40 degrees centigrade. This question may ask in interview in the written exam. If any company conduct a written exam, you can expect this question, very basic. So remember at minus 40, the difference of both the scale will be 0. But again, you see here in above or below, you can see the difference. Here minus 22 is minus 30, minus 58 is minus 50 here. But at minus 40, the scale difference is 0. Okay. So remember this point will be useful in the calculation also. Next, we'll talk about the temperature scales. So this already discussed, now heat and temperature both are not same, but interrelated. So heat is the energy and the temperature is the intensity of that energy. Okay. Next, this formula is very important. Memorize this because at the time of load calculation also this will use, because in actual practice you must know both these systems, because some consultant use English system, some will use the metric system. So or some consultant or many consultant use the mixed system. In actual practice, you see this term CFM commonly used, which is belongs to English system for this ducting side, but the duct fabrication and duct designing in that will use which is a metric. So we'll talk about that conversion. We'll talk about the units in this chapter 3 only. Just I'm trying to give the idea so that you must you must memorize this conversion. This is very important. So remember, C equal to F minus 32 by 1.8. So here F minus 32. So why we are subtracting 32 to get centigrade? Because this is 0 and this is 32 now. So that this is the first reason. So this centigrade, if you want to convert this Fahrenheit to centigrade, the first factor is you need to subtract this 32, because this is 0, this is 32. No confusion, na? For example, you see this is 30, this is 86. But okay, don't follow this. Just at this level 0.32, because here you cannot understand this 0.32. So first point, why we are subtracting this 32 in the formula, I think there is no confusion. Now the question is why we are considering this 1.8. Remember,
so in the centigrade scale there is 100 division, but in Fahrenheit scale there is 180 division.
Very good. You see here, this is 0, this is 32, this is 100, and this is 212. So 0 to 100, this is 100 divisions. But 32 to 212, how many divisions? 180.
180.
So it means one division of the centigrade is nearly 1.8 of Fahrenheit. This is one division. This is what? 1.8. Suppose this is 0.8. Getting my point? So one division of centigrade is equal to 1.8 division of Fahrenheit. That's the reason in the formula we are using this 1.8 to get dividing with 1.8 to get the result in centigrade. Just I'm trying to give the concept. Nobody will ask in that much of detail in interview, but as an engineer, you should aware of this. In interview, they may ask the formula. So C equal to F minus 32 by 1.8. Getting a point online?
Yes.
Now, similarly, F equal to what? 1.8 C plus 32, because here we are subtracting, here we are adding, here we are dividing, here we are multiplying, because this Fahrenheit is 1.8 division, no? So we need to increase that division. Okay, and 32 we are adding. But remember, this is for temperature to temperature conversion. Remember, in case if you are converting this temperature difference, in case of temperature difference, this 32 factor is not applicable. For example, you see 30 degrees centigrade minus 20 degrees centigrade. This is what? 10 degrees centigrade. Na? This 10 degrees centigrade, if I convert this with this formula, you see 10 degrees centigrade. Na? So F equal to 1.8 C plus 32. Can you please calculate this? 1.8 multiply with 10 plus 32. Can you please do it?
50.
This is 50 degree Fahrenheit. So this is going to be a big wrong. Here, 10 degree centigrade in terms of Fahrenheit is 50. There is no confusion in this. But why I'm saying this is wrong? Because this 10 degree centigrade is not a temperature on the scale. No? This is a difference of these two temperatures. So in that case, the starting point is not applicable. This stuff difference 32.
Sir, I don't. Please repeat it.
You see, if I say the room temperature say 10 degrees centigrade, in that case, you can say it's 50 degree Fahrenheit. That's correct. Because you see 10 degree in this is 50 degree Fahrenheit. But if I say the difference of the two rooms, for example, room 1 and room 2, room 1 said 30 degrees centigrade and room 2 said 20 degrees centigrade. So the difference of these two, delta T is what? 10 degrees centigrade. So this 10 degrees centigrade is not a temperature of the space. No, it's a difference of the two temperatures. So for difference, you see the starting difference 0 and 32, this difference is not applicable. We need to consider only the division difference. The division is what? 1 equal to 1.8. 1 degree centigrade is equal to 1.8 degree Fahrenheit. This is very, very important. At the time of load calculation also we'll use this. So remember, if you want to convert temperature to temperature, one can use this formula. C equal to F minus 32 by 1.8 or F equal to 1.8 multiply with C plus 32. No confusion. But in case if you want to convert this temperature difference, in that case, you see here, F by 1.8. 32 is not in this formula. Similarly, F equal to 1.8 C plus 32 is not applicable in this. So this is for what? This is for temperature difference. So remember, when you are converting a temperature, use this formula. When you want to convert temperature difference, then 32 is not applicable. You can use these formulas. Very, very important. Clear online? Very basic and important. We'll use this at the time of load calculation. And you see, now if I use this conversion, suppose 10 degrees centigrade is a what? Delta T, temperature difference. Na? So now if you use to convert into centigrade, then 1.8 into 10. This is going to be 18.9. Say round off to 19 degree Fahrenheit. So previously we got 50 degree Fahrenheit. Now we got 19 degree Fahrenheit. You see the difference is more than double.
So why it's 18.9 should be 18?
0.9, na? Above 0.5, we are taking higher value. Below 0.5, we're taking lower value. Okay.
No, sir. 1.8 into 10. Na?
Mm-hmm.
It's 18. 1.8 into 10. Sir, 10 degrees Celsius.
Okay, sorry, my mistake. So I consider 18. Okay. So you see, previously it was 50, now it's 18. So you see the difference is more than what? Double. So got the idea online? the importance of this temperature in the temperature scale formulas, or is what we can do, one can convert this into Kelvin, then you can use the conversion, but the end result is going to be same. So we have a direct formulas. Okay, so whatever, if you have any other technique, or if you want to convert both into Kelvin from the zero, you can do that one, but it will be a lengthy process. So we have this direct formulas for temperature and temperature difference. Clear online? Next, you see I've given the note also at -40, the difference between both the scale will be 0.